Okay, so chapter 8, we only focus on two sections, the arc length and the surface area. Okay, so uh, we need to define what the arc length and surface area means in chapter 8. Okay, so arc length means if you have, let me just draw as just illustrations for you. Maybe I will draw to. Okay. Okay, see the curves. Okay, I drew both curves. Okay, the orange one. Okay, see the line. Let's say we have the line from the interval A to B. Okay, so the arc length, or let me give you some idea for what the arc mean. Maybe you don't familiar with arc means. Okay, so arc is actually if you see like if you imagine like archer, okay, like a bow and arrow. The bow curve, we call it its arc, okay? Or like in circle, the curve is called the arc. Okay? So the arc length means the length of the, if you imagine the bow, that curve it has a line, and that is what the arc length means. So if you have any curves, like for example this orange one here from A to B, imagine it's like a rope, and we can stretch and we can measure the length, right? So it's similar to that. Okay? So the arc length is if you have any curve from any interval, like from A to B, and you want to measure its length, we can do that. Okay. So first step is the arc length and surface area. Remember when you have the volume, you have the this curve, okay, the orange curve. You rotate, maybe rotate to the x-axis, rotate here to give you the imagination. So rotate that. Imagine that it will be like a some solid, right? But the surface area, we only calculate the area on the surface, okay, not the volume. Okay, so the area. So that is the other case. Okay, and arc length will be related to surface area. So imagine if you rotate. Okay, if you rotate this, imagine that the this curly curve you can stretch and make a like a straight line, right? So the surface area is also the same. You can stretch and maybe it will be like a rectangle. Right? If you stretch, so you take like a paper and you can stretch and make a rectangle. So that's our approach. Okay, so uh, you will have some idea. Okay? So let me continue the arc length. So let me just make a random curves like that. Okay, and maybe making. I will divide the curves by segments. Let's say we have from this one and maybe around this, and maybe here, maybe just P0, 1, 2, and then the other maybe here. Let's say this is Pn. Let's say this Pi minus 1 Pi. Okay. Okay. Imagine the curve. I want to set the curve. I want to stretch it like a rope, like we imagine with the curves. Okay. So we stretch, and the good idea, or maybe the good approximation to stretch the curve is imagine like a tangent line. Okay? If you move point from from A to B, if you move this and imagine the tangent line, you can have the tangent line like this, right? So actually, if you plus the tangent line and you cut the segments smaller and smaller, we can approximate the length, okay, through tangent line. Okay, so let's do that, but let's just make the segment 1, 2, 3, 4, 5, 6, yeah, around 7 to see what it looks like. Okay, so maybe first that, and then the second, and we connect all the points. Okay, so imagine this is the tangent. Okay, that's at certain point, and then the other. Okay, and let me define the interval is from A, and then this is maybe the x1, this is x2. I will just note the important notations. Okay. And then the last one is the B. Okay, so from A to B. Okay, if the curves is the functions of x, we can define the length of curve y equal f of x from A to B. Let's say it's L, okay, it's equal. Let's say we divide the curve by segments, okay, and the L is actually is the total of one segment, the second, third, fourth, five. We combine all, okay, we plus, okay, and then it's become our L. So we can say if we define from P I minus 1 to Pi, the distance, okay, let me write this is the distance. Okay, so that is the first definition. So if we define the, let's say, delta yi, this is for the distance of y. And if we plug into the distance formula, you can have the Pythagorean. Okay, so imagine it's like maybe here, okay, like a triangle, and this is delta y, delta x. Okay, so you can have the relations for delta y, delta x to find the distance. Okay, to find the Pythagorean formula. So I can write here x I xi minus 1 squared plus and I can write this as a delta to simplify our calculations. So delta x plus delta y, because I'm writing I, okay, maybe I like that. And actually our distance, we can put this formula into another formula, or you can write y also fine. And this is delta yi. We can also write this. This is maybe delta x. Okay. Or actually, you can also see from this. This is from the mean value theorem. If you are familiar, this is mean value theorem. And if you see the last formula, okay, if you see the f prime at the xi, it's actually delta y over delta x. It's actually our tangent, right? Our tangent. It's our tangent. So actually, what we did is we plus the tangent, all the tangent, and then that is our L. Okay. So let me go to another formula to see how it works. And let's combine this to the distance formula. Let me write here. Okay. And we substitute the delta y with the tangent. Okay. So we can write this. Okay. And then I can move the delta x, factorize the delta x. And then we have 1 plus, and it has squared. Now we can write the formula as limit. Okay, so L limit as n approaches infinity. So sum. Okay, so we plus all the segments. And we get this. And then delta x. Or based on our previous knowledge that this sum is actually integration from a to b of 1 square root of 1 plus f prime x, and then squared, and then dx. Okay, so this is if f continues on a b, and x is from a to b in between, and y is x. Or you can write the f prime as dy dx. This is also okay if you want to write that like this. This is also fine. Okay, I think that will be the first our first approach. So by definitions, if we want to approach with the mean value theorem, in which that the x is in between of the AB, we can approach with the mean value theorem, and we can have this all this formula. And notice that it has the x, right? But it can also be dy. Okay? We can switch. Okay? And this can be a switch. Okay? Switching depends on the functions. Okay, any questions first? Any questions? I will give you another approach that I think maybe for some of you maybe better instead of this approach. The same formula, but we can approach with two methods. This is intuitively using the mean value theorem, to get this formula. The other one is through the geometric. Okay. Right. I think we can see the geometric approach. Okay. I think that will be easier. I think for me it's much easier to have the geometric, because you can imagine with the drawing. Okay. Okay, let's say that's a curve. Okay. Like I said before, that the L is actually a small tangent line, and we add all that tangent line. Okay. So let's make some point here. So let's say this is the tangent line. Let's say P. And let's say this is very small, and we can write this as dy and then dx. Okay. And let's say our tangent, the gradient, let's say it's dl. And we only prove this through the Pathogram formula, in which we have dl is actually square root of dx squared plus dy squared. Okay. And then we try to rewrite the formula. Let's write dx stay dx, and dy become dx squared, and then this become dy over dx squared. Okay. Now dl become, I will move the dx outside, and then I get this 1 plus dy over dx squared. Okay. And I will integrate both. So L will be, okay, and it results in the same formula. Okay. I think this will be, I think for me personally, I'm suggesting this way to remember how you get this formula. Okay. So imagine the tangent line. Okay. Imagine the tangent line. And why you need to integrate this is because we need to have, oh, I forgot the integrations. Sorry. Let's say this AB. Okay. Because what you need to do is you need to plus all the DL. Okay. So you imagine you have DL, 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 and then you get this. Okay. So if you have a basic formula, if you have basic concept of calculus, you can go directly to this one. Okay. If you want to, let's say, define from the scratch, then the previous formula. Okay. So you define the segments, you define the distance. Okay. And all will be proven. Okay? And this way is much more better if you already know what is calculus, what is the integrations means. Okay. So I think this is approach if you are maybe forgetting what is the correct formula. Okay. You can start from drawing random curve, and maybe took one sample, make a tangent line, make a triangle, and then you need to define the DL. Okay, find the DL, and you can define this as dx or dy. Depends. Okay, depends. If you want to be a dx, then this is dx, and then 1 plus this is dy over dx. If you want to make it dy, then it will be dx over dy. Okay. And then the AB is the interval that is usually given in the information, or you want to assume or just make it any point that is defined. Okay. So it need to be continuous function on A to B. Okay, continuous function. Okay. Okay, that is the arc length. Okay, still about the arc length, we can also describe the arc length into we call the arc length function. Okay, arc length functions. Let's say if curve C has an equation, let's say y equal f of x, and A is, and let define, we call maybe S function S. This is distance along curve C from let's say initial point to Q. We can write the arc length functions as the Sx from A to X. We call this is the arc length functions. Okay, the arc length function, and it's actually similar to fundamental theorem of calculus. Okay, they do the structure. So we can also, if we want to derive this dx over dx, this is actually 1 plus f prime of x, or you can make it as dy over dx. So in differentials, you can write ds as 1 plus dy over dx squared and then dx, or 1 plus dx over dy squared dy in differential forms. Okay. So because we now have similar structures to what we did in the fundamental theorem of calculus, so in the final exam, it's from chapter 5 to 8, but maybe the problem will be combined from more than one chapters. Okay, so maybe it's not necessarily just to find the arc length function, but maybe you need to relate the arc length function with the fundamental theorem of calculus, okay? Or maybe relate to also limit. It's also possible. Okay? So the final is from chapter 5 to 8, but actually to solve 5 to 8, you need at least some basic concept from 1 to 4, which is the limit, the derivative, okay, all the derivative techniques, the product rule, and etc. And relate to the integrations. Okay, okay, that's the arc length functions. Let me give you just a simple practice or simple questions. Okay, how to use the arc length functions. So if you have functions y equal x squared minus 1 over 8 ln x, taking a starting point. So if you just need to find the arc length functions, what you need to do is we need to find the, let's say if this is f of x, we need to find the first derivative, and then we squared, and then plus 1 to make it the form that we want to approach. And we have now this form, and we can make it to standard form of the quadratic formula. And we get now this. So this is 1 plus f prime x and then squared. Now we have this. What we need to do is we need to add the square root. So square root of 1 plus f prime x squared is 2x plus. So we can write the sx, let's say from the initial point, we can write this is 2t plus, or we can write this as t squared plus and then maybe we can finish this, and we can have this as our arc length functions. Okay. So arc length functions, at the end of the day, if you are calculating the definite one, if you already have the initial point, it will be resulting a functions. Okay, a functions. But if the question is asking the definite number of the arc length, it will be having, so as maybe just the integration is not from 1 to x, or maybe some interval, definite interval. So that's the direct approach. Okay, the direct approach. So actually, I'm just preparing for today is all the concept for the arc length and the surface area. And next Friday, this Friday, I will maybe having some exercise of most of the chapters that we will include in the final. So after this arc length, I will move to the surface area. Okay. Any questions? Questions? Okay. Okay. Let me just write a new page and start from the area of surface or surface area. Area of surface revolution. Before I'm going to into details, let me just draw a simple geometric form. Let's say this is a cylinder. Let's say the radius is r for the circle, and the height will be h. Okay, and that, like I said before, if we are trying to find the surface area, okay, of the lateral surface area, so I will write this lateral surface area. We can take the rectangle one, and we can make it maybe that, like that, okay, and maybe this is the h, and this part will be the 2 pi r. Okay, so the area will be 2 pi r and h. Okay, that's for the cylinder. Okay, cylinder. Okay, now the other simple geometric, this is just to remind you how to find the surface area, and also to find our approach to find if we have a curve, and then later we will rotate. Okay. The other one is the cone. The cone, let's say it's same, it has a radius r, and then let's cut the cone here. Okay, cut. And we can open the cone maybe like that. Okay, it's not good scale, but yeah, almost like this. Okay, and let's say we have theta here, and this will be let's say this is the length here is L, so I can write down L here, and this one will be 2 pi r. It's the circle, right? And the length of this 2 pi r, if we relate to if we imagine this is the big circle, right? This 2 pi r is equal to L theta, okay? Right? So area of this shape will be theta over 2 pi multiplied by pi L squared. Okay, so I can write this as this half L squared theta. Okay, and theta from this formula is 2 pi r over L. Okay, so I also can substitute the theta with 2 pi r over L, and I can cancel this, and also cancel 2, So area will be pi r and l. It's the surface area. It's the surface area of cone. Okay. Now we have the cylinder. We have cone. Let me make another one shape. The other one, let me draw this. Okay, it's called the frustum. This is cone. This is frustum. It's like a big cone. Let me draw the like the cone here. So if you see uh, how we get the area for the frustum, I can write this as area of I will write a big cone, okay, big cone minus area of small cone. Okay. Let's say this is L1 and the bottom one here is just L. This part is R1. It's a circle. Okay, it's a circle. And this part is R2. Okay. And we have this height. Okay. Okay, based on what we did on cone, let me write the area for the big cone. The radius is R2, so I can write this pi R2. The big cone, so I need to plus the L1 plus L. Okay, and the area of the small cone is R1 and L1. So pi R1 and L1. Okay, so I need to subtract this. So the area of the frustum so let me simplify. And let me write the or maybe I can write this R2 minus R1 L1 plus R2 L. Okay, yeah. So this is the area. Okay. Now, if we are seeing this triangle, let me draw the triangle. This is R2, R1, L1, and L. I can write this L1 over R1 is L1 plus L over R2. Okay. From the triangle. And I can write the L1 R2 is R1 L1 plus L. And I can solve this, and let me solve this with R1L equal R2L1 minus R1L1. Yeah. So R1L is R2 minus R1L1. So let me write the conclusions. So area, or let me write the area of first term is become pi R1L plus R2L. If okay, R is, we define R as the average radius. Okay. Then A is 2 pi RL. Okay, why this is important? Because what we will get, okay, from this kind of curve, so we rotate. If we cut the curve, the segments, the surface segments will look like a frustum. Okay, so if I draw here, maybe like that, okay, and I want to rotate here. So it will be like that, right? So if I take a segment like from here to here, we can see this is like a frustum. So we can approach, okay, we can approach this blue area here with this formula, okay, from the cone, right? From the cone, you cut the cone, you get the frustum, and you go approaching this area with the frustum formula. Okay. Do you want to write from the beginning, from here? I think the important one here, the frustum. Yeah. Okay. Is this your quiz questions? No, right? Oh, the other class. Yeah. Your question is the sphere, right? Sphere. Sphere, right? I'll find the volume of sphere. Okay. Yeah. And later I will maybe upload maybe all the files, also from the notes from the other class, like from the quizzes, and also from the previous final exam. I gave you the 2019, right? Or have I sent to you in the Moodle last year final? Huh? Yes, right? Okay. You can check again the Moodle system. Maybe I can also send you another one, the 2018. But I think 2018 also already, right? Okay. Okay, let's continue a little bit. Oh, by the way, do you have other schedule like the final? Already have? Not yet? Like physics? No? Not yet? Really? Did the professor didn't have you doesn't give you the schedule? When? Tuesday? Okay. Material science. How about chemistry? Wednesday? Oh, not yet. Not yet. So what other course you have that may have the final? Or is there any final this week for you? No. Or all the next week? Or maybe next 2 weeks? Next week. Okay, okay, okay. So so calculus will be the last one? Or is there any other course? The last one? Okay. 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 I hope you get a good result. Yeah. All professor want the students have a good results. Okay. But okay, there is a but because based on I think statistics, okay, statistics that there are certain amount of uh, standard that the class should have, like the average should be like some points, okay, and we need to follow that rules. So in order to follow that rules, that I need to make a distribution. Okay? So I need to make a distribution. For example, like if you have like 10 students in the class and they have like average results, maybe 50 or 60 average results. But I need to make a groups. Okay, which one is the middle one? Usually it should be the highest number, and which one at the some 5% or 10% at the top, on 5 or 10% at the bottom. And I need to make distributions. Okay? And based on that distribution, the grade A, B, C will be appearing. Okay? So the ABC is resulted from that distribution. And also in my course, the ABC first is we will see the NTSC standards, in which the NTSC standards you can check in I think in the website, or I think in the website they have. But usually if you print the transcript, at the backside of the transcript there will be like explanation, what is A, what is B, what is C, how much the score. So for example, if C is around maybe 60 or 65, 60 to 65 is C, in my course, maybe around that number, but maybe lower than that, maybe 50, almost 60, I can make it C. But it also depends on your results. It can be higher, it can be lower, based on the average and distributions. Okay? So that's how the grade will be. Okay, the next one is how to prove the surface area. Oh wait, I forgot to. Okay. Okay, now uh, okay, let's make the some curves. Okay. Let's say this P O, and let's say I may make a bigger to see the shape clearly. Let's write the pi minus 1 and pi, this point. And maybe here is pn, okay? And let's say this is A, this is B, okay? And let L is the distance of pi minus 1 and pi, okay? So this is where the connections, the surface area, and the arc length, okay? Before you are calculating this L, right? Your DL, 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 and become L, okay? And now, to, to, to calculate the surface area, you need this L, right? You need this L for the frustum. So this L is came from the distance, and it's also the same as the arc length. I will write this is it's actually the arc length. And let's define the average radius as R is half of R1 plus R2. And the surface area, as we did before, let me write in terms of 2 pi and then divided by 2 and the L. So this is actually 2 pi R L. Or let me write this is R, okay, from here. So let me write the arc length or the distance as the 1 plus okay. So area will be 2 pi and then delta x. And if we have limit as n approach infinity, let's say this is from equal 1 to pi. Let's say this is the fxi, the whole y plus yi over 2. And this is, oh sorry, it's squared. And delta x. So s will be a b 2 pi f of x, the square root of 1 plus, or maybe the I will be disappear. Sorry, so it's just x. And now we have this surface area. So notice that this is actually the arc line. This is the L, or arc line. This is y equal fx, continuous on a, b, and x is from a to b. You can also write the formula, the first in y, okay, 1 plus dy over dx squared and then dx. Or you can write, let's say from c d 2 pi y 1 plus, this is also you can write. Okay. Okay. So the arc length, you can choose dy over dx, dx over dy. Same thing. Depends on your integrations. Okay. But for this 2 pi y, if we rotate to the x, it will be 2 pi 1. Okay. Later I will draw the picture so you can have you can imagine the y. But if you rotate to y, it will be 2 pi x. Okay. It will be the difference here. But in the arc length, it's actually you can write dy over dx, dx over dy. Same thing. Okay. But careful with the interval when you calculate. Okay. So that's this surface. Let me write this summary. Okay, summary on how you are using the surface area. Okay. So 4 rotations about x-axis. Let me write just ds, okay? And let me draw first. This is y, and the circumference will be 2 pi y. So this will be the radius, and this is the circumference. And ds is the arc length. And 2 for rotation about the y-axis. Okay, let's say that is the function. So this will be x, okay, the radius will be x. And the circumference is 2 pi x. So I can write this right here. So this is radius, this is circumference, this is the arc length. Okay. So that's this summary how you are using the formula. Okay. You can have the 2 pi x or 2 pi y. It depends the rotation. The rotations like this one or with about the y-axis. Okay. Okay. Any questions? Now, do you have any other assignments, any homework quiz today or tomorrow? I'm offering to you, we still have around 20 minutes or 25 minutes. If you want to have other, to finish other assignments that I can finish just now up until here. If not, then I give you uh, another notes. But the chapter 8 is just finished here. Yeah, just finished here. So we only have two, only arc length and surface area. Because the other part is more physics, so I don't think it's possible because you already have a lot of contents. Okay? From the chapter 5, 6, 7, 8 is already a lot. And I can combine all in the one slide. So do you want to stop now or let me continue? Up to you, up to you. Up to you. Yeah, I will upload to Moodle. I will upload maybe the chapter. Have I uploaded the chapter 7? I think I will upload the chapter 7 and chapter 8 to the Moodle. This notes. Okay. Okay. But I think the chapter 8, what you need to do is remember the arc length and the surface area. This one. Okay. If you remember the arc length, you can get the arc length here to find the surface area. Okay. Okay. Oh, let you stop here. Okay. Is that okay? And you can have time for rest or have lunch. Okay. Because I also have a lot of quizzes to be graded. Okay. Okay, I think that's it for today. Okay. And this Friday I will deliver the quiz, and we will have some exercise or practice